An AI can invent a fake court case, compete with fake page numbers, and sound more sure of it than the lawyer standing next to it. Kuro's not making that up. It happened in a real federal courtroom, and this slap gets worse the smarter the model gets. That case never existed. The AI wrote it anyway, and never once hesitated. This isn't a hypothetical. It actually happened in a real courtroom. Lawyer Steven Schwartz asked ChatGPT for supporting cases and got 6. The judge checked. Not one of those cases existed, and the AI never once sounded unsure. So what actually happened inside that chatbot? It didn't lie. Exactly. Lying needs knowing the truth and hiding it. It generated something fluent, specific, and confident. Just not real. Engineers call this a hallucination, a name that describes it but doesn't explain why it keeps happening. Before Kuro explains why, guess first, is this a bug or something deeper? Drop your guess below, we'll come back to it. Kuro's holding off on the answer for one more beat. First, here's what an LLM is actually doing when it writes anything. It's not a database, it's not looking anything up in real time. It's a neural network, predicting one word at a time. On what basis exactly? Here's the actual mechanism laid bare. Every possible next word gets a probability score across the model's whole vocabulary. Whichever word scores highest usually gets picked next. Then, it does the exact same thing again, one word at a time, and nowhere in that loop does anything check if it's true. This isn't a mystery bug. Researchers actually explained it. OpenAI's own paper says training rewards confident guessing over saying, I don't know. It's like a test that scores blanks as harshly as wrong answers, so guessing wins, even when the guess is fiction. There's an even deeper trade-off baked into how these models learn. A model that generalizes past its exact training data will sometimes say something false. A model that never hallucinates has to stay narrow enough to never leave safe ground. You can't have unlimited fluency and zero hallucination. Something gives. If you had to pick a model that's occasionally wrong or one that's often unhelpfully vague, there's no free option here. Which trade would you make? Here's what makes this genuinely dangerous, not just annoying. A hallucinated answer usually doesn't sound uncertain. It sounds completely sure. No shaky voice, no hedge, just fluent confidence, pointed at nothing real. So how would you even catch it? So how bad is this, actually, on real current models? The Vectara leaderboard tracks exactly this, across frontier models. Rates now run from about 3% up past 12%, depending on the model and task. Better than a couple years ago, nowhere near zero, and one category of model actually makes it worse. Here's the twist Kuro teased back at the start, and it's real. Reasoning models, the ones that think step by step, often hallucinate more on factual questions. More reasoning steps means more chances to confidently wander off from the truth, and the fixes coming up have to work around that. Why do you think longer thinking would make hallucination worse, not better? Take a guess. It's genuinely counterintuitive. The most common real fix, Kuro's already shown you once. Retrieval augmented generation hands the model real documents before it answers. Instead of guessing from memory, it's reading from something actually real, which sounds like it should fix everything. Here's the honest limitation nobody puts in the demo video. A 2005 audit found only about half of AI citations were fully backed by their source. Retrieval helps enormously. It does not make hallucination zero. So what else is out there? A second fix skips documents entirely and just asks twice. Sample the same question multiple times, then compare the answers against each other. Agree every time? Probably solid. Wildly different each time? Probably a hallucination. This trick has a name too, self-check GPT, though it's still not the fix that goes deepest. A third fix goes straight at the training incentive itself. Reward honest uncertainty during training, instead of only rewarding confident answers. One 2025 approach cut hallucinations by over 90% just by training on hard synthetic cases. But push that lever too far and push calibration too far in either direction, and you get a new problem. Overcorrect toward confidence, and it makes things up same as before. Overcorrect toward caution, and it refuses questions it could easily have answered. Somebody still has to pick where that dial sits. Would you rather your AI assistant refuse too often or guess too often? No universally right answer here, just tell Kuro your pick. People mix this up with a totally different failure mode. Let's separate them. Hallucination invents something that was never true, ever. Stale knowledge was accurate once. It's just frozen at the training cutoff date. Ask about last month's news, and I don't know that yet, isn't a hallucination at all. Which points at the real myth Kuro wants gone. One myth Kuro wants gone before wrapping up. Hallucination means the AI is broken. Not quite. It's a structural side effect of how these models are trained to generalize, not a glitch. Fixable, reducible, never fully erased with today's methods, though that line keeps moving. This isn't a solved problem, it's actively getting sharper. Newer benchmarks try to pinpoint exactly which sentence is the fabricated one. And some research aims at models flagging their own shaky spans, live, mid-answer. None of it shipped at scale yet. Let's fold this whole episode back together. The problem, next word prediction, with no built-in tooth check underneath. The cause, training that rewards confident guessing, plus a genuine generalize-or-collapse trade-off. The fixes, retrieval, self-checking, and calibration, real but never fully complete. That's why AI hallucinates, not a bug hiding in the code, but a cost of how it learns. AI moves fast, so Kuro's back next week with whatever's actually new. Has AI ever confidently made something up on you? Tell Kuro below and subscribe.